My project is using trigonometry to find the end portal in Minecraft. Introduction and why this topic. What is the end portal? In Minecraft, defeating the Ender Dragon requires finding a hidden end portal inside a stronghold underground. Strongholds can be anywhere in the massive world. Players must use items called Eyes of Ender to guide them. However, they're really hard to find, and it's a complicated resource. You have to use it smartly. But math and using triangulation helps avoid wasting those Eyes of Ender. So by the time you get to the end of the portal, you have enough to open the portal. So why this topic? Well, for the sake of the project, obviously I had to find something that connected trigonometry and in something we use in like real life, or in this case like virtual reality. Also because like it shows that game mechanics are built on like real physics and math. Sometimes it's not all just fiction. Also, this using this in Minecraft kind of mirrors real world navigation, so like GPS and astronomy. And it also motivates using math through something fun, like obviously Minecraft. The central question: how can trigonometric triangulation from two known positions and angles be used to calculate the exact coordinates of a stronghold in Minecraft? Key concept number 1: triangulation and angles. Triangulation is finding an unknown point using lines from two known locations. This is used in GPS navigation and in astronomy. Minecraft YAW parenthesis F3. So what this is, using the F3 button shows what angle you're facing, and in Minecraft they labeled this as YAW. So for the numbers, 0 degrees will be south, 90 degrees will be west, -90 will be east, and 180 will be north. Coordinate system. Minecraft uses X and Z axis. This is the horizontal axis. Y is vertical, but we don't really need this for the main formulas. The end portal exists at a specific XZ location underground. Key concept number 2: the formulas. Step 1 is converting the YAW to a math angle. We need this first equation because Minecraft's YAW increases clockwise, or the angle increases clockwise. But obviously in math, it's the opposite, it's counterclockwise. And this conversion will basically fix the issue. Step 2, the direction vectors. These give us a unit vector pointing in the direction of the Eye of Ender, traveled from our two positions that we will need for the equation. Step 3, finding intersection, or the t-value. This will solve two parametric line equations simultaneously to find where our lines will cross. Step 4, finding the stronghold coordinates, which is the whole goal of this project. This will substitute t back in to give us the XZ coordinates of the stronghold. Worked example step by step. So this is basically just using each one of the equations that I had in the previous slide. So this works for any coordinates. It's not, you don't have to go to X 100 and Z 200. It's just an example of where this player would be standing. So the first position, for example, would be X 100 and Z 200. From this position, you throw an Eye of Ender and you click F3 to show your YAW, or your angle. And to convert that first angle, you use the first equation in step 1, which in this case will give you -45. And while you're converting this angle, you're also going to use the second equation, which will give you 0.707. Then you will do the same thing for position B, except that you're going to walk approximately like 400 blocks in the X coordinate. Z will stay the same, so it'll be 200 and 200. You will throw an Eye of Ender again, and it'll obviously be different but for this example, let's say it gives us YW -135. We do the same thing we did in step 2 and use both equations. And in the end, you will use the last equation to basically give us the coordinates. In this example, we will get the coordinates 241 X and 59Z. And so this is kind of like a visual diagram of how it would look in the game. So the green point is the first position from which we threw the first Eye of Ender. The blue point is the second position where we threw the second Eye of Ender. And the orange diamond in the middle is the coordinates of what we got after using the equations. And so the further you throw your first I-vendor from your second I-vendor, it will give us a more accurate result, data and results and what they mean. So this is just a data table showing like where we threw the I-vendors from and what we got and what the results mean. The calculated coordinates tell us exactly where to dig. Once at those coordinates, we dig down to, now we use the y-axis to around 30. But really, if you're used to playing Minecraft, if you just dig down, although it's typically a bad thing, if you just dig down, you'll find the stronghold. It's very distinct from the surrounding stone and blocks. But to make it easier, you'll dig to Y30 and search within 100 blocks of the area. The math will predict where the stronghold is. You need to guess or waste eyes of Ender. And again, this mirrors how real GPS receivers triangulate your location from satellite signals, patterns, and real-world connections. Baseline distance pattern. The farther apart your two observation points, the more accurate the result. Wider baselines reduce angular error, the same principle used in GPA satellites and radio telescope arrays. Law of trigonometry. Cosine and sine convert angles to direction vectors. This is the same math that controls airplane autopilots, ship navigation, and satellite tracking. Triangulation in history. Before GPS, sailors and land surveyors used the same triangulation technique with sextants and theodolites to map continents and navigate oceans. Error and precision. Small angle measurement errors compound into large position errors. This is why we choose observation points far apart. It's the same reasons GPS uses many satellites for accuracy. Conclusion: by recording two sets, the X and Z coordinates and the YW angles from Minecraft's F3 screen, we can use trigonometric direction vectors and parametric line intersections to calculate where two sighting lines cross, or the two lines created by the eyes of Ender, revealing the stronghold's exact location. The math behind this is identical again to GPS triangulation, surveying, and astronomical triangulation, and essentially it's just a fun way to challenge ourselves instead of mindlessly wasting our resources, and making it easier for ourselves and just using math in our daily life.